Hi everybody, it's Miss Lorenz here. I'm going to talk about sixth grade 2.1, 2.2, and 2.3 all together because they're all very much connected, and also because you guys have a bit of a background already in integers. Living in Montana, you know about negative temperatures, and because of that, you have sort of grown up with a bit of an understanding of how negatives work. So that allows us to kind of do three little chunks all together. So first of all, I want to talk about the word integers. Integers are just a group of numbers. And so in mathematics, we group numbers according to different definitions. And I'm just going to talk to you about where integers falls. So our smallest group of numbers is the counting numbers. And these are the numbers that start with 1 and they go to infinity. Those include the numbers that you would have started counting when you were a toddler. You know, when you were a toddler and you were learning to count and you said 1, 2, 3, and you used your fingers, those are the counting numbers. They don't include 0. They don't include halves. They don't include decimals, fractions. They don't include negatives. They're just the counting numbers. Then, as civilization advanced, so this is like an advancement in civilization. You could say like the cavemen used counting numbers. But as civilization advanced, they realized a need for 0. And so when 0 was added to the number system, we now had a new number system called the whole numbers. So we have the counting numbers and the whole numbers. These are all considered real numbers, which is something you'll look at in 8th grade. But just keep in mind, whole numbers came next because of the addition of 0. So now we have 0, 1, 2, 3, 4, 5, but we still don't have fractions or decimals or negatives. But then as civilization advanced, they realized they needed a way to represent a loss of something or to owe something or something that is below the normal level, the 0 level. And that's when integers were born. So integers include, notice the arrows, integers include all those whole numbers. They got poured into this bucket. And it also includes the counting numbers because the counting numbers also got poured into this bucket. But now the integers are including your negatives and your positives. Then civilizations advanced even further. So now take everything that's in this integer bucket, which is the negatives and the positives and the zeros and all of those whole numbers. Everything is now in here, and this is our rational number bucket. This includes now the decimals and the fractions. So negative decimals are in here, negative fractions are in here, negative whole numbers are in here, positive whole numbers are in here. Basically everything that we're going to work with in math this year is in this bucket, the rational numbers bucket. Now, why are we talking about integers then? Well, that's because this is the first time in your math career that we have officially talked about this group of numbers, the integers. So that's where it lives. And if you think about your schooling so far, you guys, you've pretty much worked with number groups here in the whole numbers and the counting numbers. Even starting at kindergarten, these are the two groups of numbers you worked with really all the way through 5th grade. It isn't until 6th grade that you're going to now start working with integers and rational numbers together. All right, so let's talk about negatives. This is how we would read. Of course, on a number line, we have 0, and then our positive numbers go to the right of the number line, our negative numbers go to the left. And so if we were to identify this number right here, we would read that as -5. Now, I know sometimes students want to read that as -5, and I know that you mean the correct thing, but just keep in mind that the proper way to read that number is -5. And then here's an interesting piece. 0 is neither positive nor negative, so don't try to make 0 positive. Don't try to include it over here, but also don't try to include it over here. It's considered neither positive nor negative. So let's talk about some integers and where they live on the number line. So the integers that are furthest to the right are greater. So that would mean then that the integers furthest to the left are smaller. So let's go ahead and do some ordering. We know that 5 is less than 27. That's because 27 lives further to the right on the number line. But when you get into the negatives, it can kind of mess with your head a little bit because -4 is actually less than -2. And that's because it's further down on the number line. -2 would live about right here, where -4 would live right here. And see how -2 is further to the right of the number line? So it's greater than -4. 0 is greater than -10. Here's 0. Here's -10. 0 is further to the right. Then let's do these together. So -1/4. I'm going to put it right here. And -1/2. So -1/2 is going to actually be further down the number line to the left. So -1/2 is less. So in other words, -1/4 is greater than -1/2. -1/3. I should use a different color this time. -1/3 would be about right here. And -2/3 would be about right here if this was 1 now. And so you can see that -2/3 is further down the number line on the left. And so that would be less than -1/3. -5 1/4 and -5. Well, if we go back to thinking of this number here as -5, here's -5. -5 1/4 is a little bit further to the left. So it's a little bit less than -5. All right. So now let's talk about how else we read negatives and positives. So we like to think of it as the opposite. So the opposite of +10 is -10. The opposite of +5 is -5. And so the opposite is the same distance from 0 as its opposite. So 10 is the same distance from 0 as its opposite, -10. So how would you read a problem like this? -6. So I would not read it that way. I would read that as the opposite of -6. You know what the opposite of -6 is. The opposite of -6 is +6. All right. Besides temperature, you guys, I also want you to think about how we use positives and negatives with money. When you add money to an account, that is a deposit and it is a positive transaction. When you withdraw money from an account, that is subtracting money from the account, or it's a negative transaction. And you'll see this type of thing notated on even bank statements. Oftentimes you'll see plus to show a deposit and minus or a negative value for a withdrawal. All right, the last thing I want to talk about is absolute value, which I've kind of already talked about because it is associated with this idea of opposites. So if you have an absolute value symbol, it's these vertical bars around a number. So they're not parentheses, but they are vertical bars around a number, and we do want to satisfy what's inside the absolute value bars. So what this means essentially is just how far is the number inside the bars from 0. So how far is -5 from 0? Well, it's just 5. It's just 5. It's not -5 from 0. Distance can't be negative. Distance is always positive. So this distance from -5 to 0, that is a positive distance. That's 5. So the absolute value of -5 is 5. Absolute value of -10 would just be 10. So notice the absolute value of -5 is 5. The absolute value of a positive number, like this one, +6, is also a positive number. So the absolute value here is always going to be positive. Now, sometimes you'll see something like this, you guys. This, we're going to read, just like we read this one, the opposite of the absolute value of -10. So let's do what's inside the absolute value bars first. The absolute value of -10 is 10, and the opposite of 10 is -10. That is the only time where you're going to see like a negative sign associated with this is when you find the opposite of what's inside those bars. Okay, I hope that helps, and you should be able now to do everything in 2-1, 2-2, and 2-3, and then do your superset. Thanks for listening.